This is topic 7.2, area and volume of cones. And I've already labeled the parts of a cone. I'll let you do that. The lateral area on the net of a cone kind of looks like a, sort of like a triangle, but with a curve to it. It would wrap around. I have examples of these if you want to see how it actually folds up into a cone. The lateral area would be that area that wraps around the base, so that's the curved area. There's one that you need to add, the slant height. I didn't see it on here, so let's add it. The slant height is the one that's on the side of the cone. The height is the one that the perpendicular line that goes to the center of your circle. So make sure you know that there is a difference. And on the when you notice on the formula chart, this one will be an H, and this one will be kind of a cursive-y looking L on the formula. In fact, the very first formula for lateral area says pi times r times L, and it is a slant height. Be sure to refer to that on the formula chart. The total area is the sum of the lateral area and the area of the base, and the formula for that is S equals pi RL plus pi r squared. That's because it's the lateral area, the pi RL, and then the area of the circle. The volume is the number of cubic units in the interior of an object, and the formula is 1/3 the base area times the height. And if you want to go ahead and write the base area as pi r squared, you can replace the capital B with pi r squared for the area of a circle, so since that's the base. Let's use the formulas and try this first example. The lateral area formula is pi times radius times slant height, and on this one that means you're going to do pi times the radius 3 and the slant height 6. That's a pretty easy one. This one's 18 pi. And because there's no unit label, let's just use U for units. So square units. Now let's do total area. The pi RL is your lateral, and then you're going to add pi r squared. So we already did the lateral, that's 18 pi. Then you're going to add pi times the radius 3 squared. So you're adding 9 pi to 18 pi. And if you put 18 pi and you add a 9 pi to that, the answer is 27 pi. And again, since it doesn't have units, we'll write it as 27 pi units squared. For volume, it's 1/3 pi times radius squared times height. This one, now this is the one where we're going to have to figure out the height. So let me label it. This is the height on this cone. If you notice, there's a right angle right here, so it creates a right triangle. So you will have to use the Pythagorean Theorem to find the height. Let's go ahead and do that. So we're going to square the two legs to equal the square of the hypotenuse. So you're going to get h squared plus 9 is equal to 36. So h squared would equal 27. Now the square root of 27 does simplify. The simplified form of 27, since you can divide it by 9, is 3 times the square root of 3. Come see me if you need some help remembering how to simplify radicals, because we are going to keep it in this word exact means we're going to keep it in radical form. So our height on this one, we're going to do 1/3 times pi. We're going to square the radius 3 and then multiply it times 3 times the square root of 3, because that's our height. Now remember, we're going to leave it in radical form, and we're going to leave pi as a symbol. So you're really basically working with these numbers. So it's 1/3 times 3 squared, that's 1/3 times 9, that's 3, and then 3 times 3 is 9. So we keep that as a radical. So it's 9 times the square root of 3 times pi. Because it's volume, it's cubic units. Alright, example 2. Example 2 has another cone, and this one, if you notice, there's not a radius on this cone, but you do have the slant height and the height. So we're going to need to figure out the radius. Let's label it R. And again, the Pythagorean theorem is going to be the leg squared plus the other leg squared is equal to the hypotenuse squared. So that's R squared. 3 squared is 9. When you take 3 and square it, you get 9. When you square root the square root of 2, you get 2. So 9 times 2 is 18. You're going to subtract the 9, so R squared would equal 9. So in this case, your radius is 3. So this one's really not drawn to scale, because if you look at it, this height is 3 and this radius is 3. So just remember, sometimes in geometry things don't look drawn to scale. So don't worry about the picture. Just know that this is, we did the Pythagorean theorem, so we know we're doing that one right. Alright, let's use our formulas. I think I'll put it up here. For our lateral area, we'll do that one first. It's pi RL. So it's pi times 3 times the slant height, 3 times the square root of 2. Now remember, we're leaving it in exact form, so we're going to leave pi as a symbol, and we're going to leave the square root of 2. So that would be 9 times the square root of 2 pi. Let's go ahead and write it as 9 times the square root of 2 pi, and then we'll just use u for units. Units squared. That's your lateral. To do your total, let's write the word lateral. Total is when you do the lateral area and you add the circle base. We've done the lateral, and we found it to be 9 times the square root of 2 pi. So we're going to add pi times radius squared. When you square 3, you get 9. Now the answer on this one is going to remain 9 times the square root of 2 pi plus 9 pi, because you cannot combine the square root of 2, 9 times the square root of 2, with 9. So it's the unlike terms, one being the radical term, you'll leave it in exact form. It'll look like that. And that is square units. Okay, for volume, the volume formula is 1/3 the base area times the height. So it's going to be 1/3 times pi times 3 squared times the height 3. So 1/3 of 9 times 3 is 9 times 3 is 27, and 1/3 of 27 is 9. So this is 9 pi, and this is cubic units. Anytime, don't forget, your volume is always written in cubic units, and your area is always written in square units. Alright, the next one, we have the volume is already given to us, and we are asked to find the radius, the slant height, the lateral area, and the total area. And we are going to do exact answers. So we need to start with what we know, and since we know the volume, let's write that formula. The volume is 1/3 pi r squared times height. So if you notice, they already gave us the volume. They told us the exact volume was 12 pi. And I have 1/3. Oh, we know the radius too, so we know that the radius is 3 feet. So we're going to square the 3 times h. If you notice, really the only variable we're going to be left with is the h. And I'll show you what I mean by that, because you can remove the pi's. This right here is 9, and 1/3 of 9 is 3, so we could write this as 3 pi times the height is equal to 12 pi. And if you divide by 3 pi, see how the pi's divide out? So your height here is just going to be 4, because 12 pi divided by 3 pi, the pi's cancel each other out, so the height is 4. The slant height, why don't we sketch a little cone here so you can understand what we're looking at. Remember that the line coming down from the center to the vertex of the cone is your height, and they told us that was 3. Oh, I'm sorry, the radius is 3. Let me fix that. The height is 4. Okay, I hope you know and remember Pythagorean triples, because this is a Pythagorean triple. If the legs are 3 and 4, the hypotenuse has to be 5. And you can always do the Pythagorean theorem to figure that out. But that's your slant height, 5 feet. Okay, the lateral area is, let's write the formula. The lateral area is pi times radius times slant height. So that's pi times 3 times 5. So that would be 15 pi. And since we do know that it's in feet, we'll do feet squared. The total area is the lateral area plus the circle, the base. So the lateral area was 15 pi. We're adding the radius squared would be 9. 3 squared is 9, so that's 9 pi. If you add 15 and 9, that's 24 pi. So it's area, so it's 24 pi, and it is square feet since it's area. You know, I think I will go ahead and explain how I got this 5, just to refresh your memory. 3 squared plus 4 squared equals c squared. See how that's 9 and 16? 9 plus 16 is 25. So the square root of 25 is 5. You can always check your special your Pythagorean triple by using the Pythagorean theorem. Now it's time to do some work on your own. Come see me if you need some help.